Flying over the hills west of Stanford, you can see a narrow building that crosses under Interstate 280. That landmark building from the 1960s is at the heart of SLAC National Accelerator Laboratory. It's home to a linear particle accelerator, the LINAC, that accelerates electrons to almost the speed of light through a tunnel 30 feet underground. The Stanford Linear Accelerator was an audacious project for its time. The largest and most expensive instrument ever constructed for research. So big that the physicists who dreamed it up and built it called it M for monster. They were pretty sure that hitting atoms with the LINAC's high-energy beam would reveal fundamental particles that no one had ever seen before. And they were right. Discoveries in those early years won 3 of SLAC's 4 Nobel Prizes. But what they didn't anticipate was that the LINAC would give rise to so many ingenious advances, leading to the vibrant, multifaceted lab we know today. A Department of Energy National Laboratory, run by Stanford University, right in the heart of Silicon Valley. Here, nearly 2,000 employees work alongside hundreds of Stanford graduate students and thousands of visiting researchers and collaborators from around the globe. Okay, but how did we get here? The same way we began, by thinking outside the box, seizing opportunities, overcoming setbacks, and planning the next big steps, years in advance, to stay at the cutting edge of discovery. For instance, when electrons circulated in the lab's first particle collider, they gave off unwanted X-ray radiation. Researchers channeled that radiation into X-ray beams and used them for their experiments. This created a pioneering facility, now called SSRL. That was the first synchrotron to open its doors to the wider scientific community. Today, SSRL is a major contributor to discovery at SLAC, with experiments ranging from studying coronaviruses to understanding how to break down plastics, build better batteries, and develop treatments for ailments like flu and melanoma. SLAC also transformed the linear accelerator into a revolutionary tool for science. This is LCLS, the world's first X-ray free electron laser. It uses the LINAC's electron beam to generate X-ray pulses 1 billion times brighter than anything available before. Its successful opening in 2009 and important early discoveries set off a race to build X-ray lasers around the world. As LCLS opened, SLAC and its collaborators were already planning a major upgrade. They installed a new superconducting accelerator in the tunnel alongside the existing LINAC, chilled to nearly the temperature of outer space, so it could accelerate electrons with almost perfect efficiency. This superconducting accelerator switched on in 2023. When it's running full tilt, it'll produce X-ray laser pulses so bright and so fast, up to 1 million pulses per second. We'll be able to see all the way down to the electrons and observe them at the speed that they move at. Working together, the 2 accelerators will boost the pace, precision, and range of discovery at LCLS. Today, SLAC is a world-leading center for X-ray science, paving the way for the international research community. We use immensely powerful X-ray beams as microscopes to probe gases, liquids, and solids, to look at all the molecular machines that power all living things in far more detail than ever before, and, in some cases, right down to the level of individual atoms. pushing the boundaries of accelerator and detector technology to make molecular movies of chemical reactions unfolding over a few billionths of a second, to understand the ultra-fast processes that govern how the world works at a fundamental level, to create and explore extreme states of matter, like the stuff found in stars and in the hearts of planets, work that could also help in developing fusion energy. Our researchers also play a leading role in the quest to discover new fundamental particles and forces, understand the nature of dark matter and dark energy, unlock the secrets of ghostly neutrinos, and observe light from the earliest moments of the universe. To explore the cosmos on the grandest scale, SLAC built the world's largest digital camera ever made for astrophysics and cosmology for the Vera Rubin Observatory in Chile. It will scan the entire visible sky for a decade, revealing clues to the nature of dark matter and dark energy, as well as other mysteries of the cosmos. Stanford manages the lab for the Department of Energy, Office of Science, and our growing partnership is crucial to carrying out our scientific vision. We collaborate through 6 joint institutes and centers that focus on developing new materials and chemical processes, understanding the physics of the universe, advancing ultra-fast science and battery research, and getting amazing 3D views of life's machinery with cryogenic electron microscopy. SLAC and Stanford also work together on initiatives to advance quantum information science and sustainability, innovative approaches to scientific computing to manage the massive amounts of data streaming from all our experiments. SLAC people make all of this possible. Some of the brightest minds in science, engineering, and technology. Plus, a highly skilled, creative staff whose operational expertise keeps the lab running smoothly. By living our shared values and bringing together a rich diversity of perspectives and experiences across many fields, we accomplish more together. We're passionate about our purpose and share it with the world through lectures, tours, and summer camps, inspiring the next generation to pursue careers in science, technology, and engineering. The imagination, grit, and teamwork that SLAC people put into their work, along with our many collaborators around the globe, produce scientific advances that bring people together and continually bring humanity closer to the truth.